Welcome to another video for chemistry. In this video we're discussing SPDF blocks or orbitals. So these are actually orbitals. Orbitals meaning these are the spaces in which you are more probable to find an electron. Okay, and these orbital shapes actually coincide with the periodic table. Okay, so our s orbital electrons are in groups 1 and 2. Transitional elements have the d orbitals. Our p orbitals are with our nonmetals and halogens and noble gases. And then our lanthanide and actinide series will have our f orbitals. Okay? So each is a very different type of orbital. It has a different shape, different energy level, and depending on how many electrons you have, that will determine how many of these orbitals will be inhabited. It's kind of like if I come into a hotel with a busload of people. I don't just put that entire busload of people into one room. I will in a very organized way place them appropriately in different rooms. So each person will inhabit a specific room. So when the first floor, if you will, after the first floor is full of people and I've evenly placed them in the room, I will then move on to the second floor. And then as that second floor gets full, then I will move on to the third, and so on and so forth. And that's exactly what happens with these electrons, is that as I add more electrons, the bigger the element is, the more electrons it will have, the more rooms these electrons will fill, the more orbitals they will fill. And each orbital can fit a maximum of 2 electrons. Okay? So if I'm looking at the s orbital, I have one orbital, so that would be 2 electrons. My d block has 10 electrons, so if I count these out from here to here, that's 10 electrons. I would add up, so I could have 5 orbitals. And then in my p block, that's 6, 1, 2, 3, 4, 5, 6, so it means I can have a maximum of 3. Now notice here, helium actually will belong with the s orbital. Okay, the only reason why I have helium over here is because of its behavior. It behaves like a noble gas. Okay, and then of course my f block has 7 because I have 14 possible electrons that I can fit in, so I'm going to need 7 orbitals. Okay, so it's like if I have 14 people and I can only fit 2 people per room, then I'm going to need 7 rooms. And the math works the same way in these different orbitals. So the shapes of these orbitals are as such, and these are my main group elements here. My s orbital, okay, my group 1 and 2, it has a spherical shape. Okay, my p block orbitals have a dumbbell shape. Okay, and they take up space in different coordinate planes, so they're not overlapping on each other. So when I superimpose them, you can kind of see the complicated shape that they make and where the electrons are at. Now keep in mind, this is not the exact location of the electrons. These are the most probable locations of electrons, because electrons move so fast you can never really tell where exactly an electron is at any given point in time. You can only give a probability of where it's located. So this is the most probable location for electrons that are from the p orbital, from boron all the way down to radon. Okay, so let's take a look at the other shapes. So this is a chart of all the shapes of the orbitals. So again, my s orbital is a spherical shape, and the bigger the element is, the bigger that spherical shape will be. Here's my p orbital dumbbell shape, and then my d orbitals. Now you'll notice that these orbitals are getting more and more complicated in shape. So d has 5 orbitals, and then my f, super complicated. Okay, so 7 orbitals for my f series. So this naming system will come into play when we organize these electrons using our orbital diagrams and electron configuration. Okay, that does it for the introduction for the SPDF blocks, and our next videos we'll be working out some of these problems so you can actually see how this concept works. Good luck in your studying.